So let's check this out. What if my a value is not equal to 1 and I want to factor a quadratic? So let's factor the quadratic 2x squared plus 17x plus 30 using the AC method. All right, so I'm going to set up a couple of things. I'm going to really try to visualize this problem by setting up my box, all right, where I know that I'm going to have a set of expressions that multiply to be 2x squared and a set of expressions that multiply to be 30, right? My unknown is these two diagonals because factored form or standard form gives me only a b value, which I know is the combination of two different values. So I use my AC method. AC, let's start with the product AC. Well, my a value is 2, my c value is 30, therefore AC equals 60. My b value, let me just list it. My b value is 17. In other words, I'm looking for two numbers whose product is 60 and whose sum is 17. Well, those two numbers are 12 and 5. All right, which means that I can write those numbers in either one of these boxes. So I'm going to go ahead and say that this is going to be my 12x and this one's going to be my 5x. Now, it helps to use this box instead of, I also have it right here on the side where you can just go step by step. All right, if you're a visual learner like me, you can use the box though. All right, at this point, I start factoring. So I'm going to start right here up top. What number will go into both 2 and 5? Well, that's just 1. All right, and what expression will go into x? X squared and x, well, that'll be x. So that's my x. Then I think, well, what expression could I multiply x by to get 2x squared? Well, that would make this guy 2x. Then I can just go, well, 2x times what would give me 12x? Well, that would have to be a 6, right? A positive 6, by the way. Then what number would I multiply positive 6 to get 30? Well, that would have to be a positive 5. Notice also how positive 5 times x gives me 5x. So it's kind of like a puzzle, and it all worked out. My answer is x plus 6 times 2x plus 5. Now let's try another one. So let's say we have 2x squared plus 9x plus 9. 2x squared, top left box, 9, bottom right box. I'm just visualizing this. I want to think, well, what two numbers will satisfy A, C, and B? My AC is going to be 2 times 9, which is 18. I need two numbers that multiply to 18, but whose sum is 9. Those numbers are 6 and 3. So I can go ahead and fill in 6x and 3x. You see, the AC method just helps me discover what those two separate diagonals are. All right, now I can start factoring. What expression will go into 2x squared and 6x? Well, that would be a 2x. That makes this guy an x, which makes this guy a positive 3, and this one's a positive 3 as well. So we end up with 2x plus 3 times x plus 3 as the correct factored form. Let's try one more. 6x squared minus 25x plus 21. My AC is going to be equal to 6 times 21, which is 126. 126. Let's rewrite that. So 126. My B value is just negative 25. Now, one thing I noticed right here is that my final product is positive. Therefore, these two diagonals have to be negative. A negative times a negative is a positive. So you might have to look a little more for this one, but it turns out that those two numbers are negative 18 and negative 7. All right, well, I'm going to attach my x, negative 18x and 7x. So I look for a common factor in 6x squared and negative 7x. Well, nothing fits except x. But between 6x squared and negative 18x, well, that's going to be a 6x. That'll go into both. All right, look how everything works out. X times negative 7 will give me negative 7x. And I can have a negative 3 right here because negative 3 times negative 7 will be 21. Final answer, x minus 3 times 6x minus 7. Cool little trick as you're trying out this factoring process is take a look at your original parabola. As you try to find the correct factored form, your final answer should graph the same parabola. That is how you factor when a is not equal to 1.